All right, hello everyone. Welcome to CS220 or CS319. My name is Cole Nelson. I'll be your instructor for this semester. As you can tell, I am not in the lecture room right now. This is actually a re-recording of the lecture from this morning. We had some technical difficulties while trying to record it. In the future, everything will be available by Piazza, but this particular lecture will be uploaded by me because I'm re-recording it. So, welcome to 220. What are we going to be covering this semester? Well, this is all about Data Science Programming 1, and a little bit about myself. My background is in software engineering, and it's in cybersecurity, and I was able to get through computer science without touching data science too much, which is absolutely no longer the case even in these past couple of years. Data science has become super prevalent in fields beyond computer science. You know, the list a few: journalism, biology, physics, chemistry, psychology. It'd be better to list majors that don't use data science than do, right? Because it's just so prevalent in so many areas. Taking a look at some of the examples on the screen here, you'll see neuroimaging is really important for, or data science is really important for neuroimaging, right? Because when we look at the brain and we know that the left side is the more logical and the right side is the more creative, well, how are we able to know that? Because the brain isn't labeled like that. It's not like you can look at it and say, yep, this is the logical and this is the creative. It's you give people logical, maybe math related tasks, and you give people creative tasks, and you measure brain activity during that time. You gather all of this data, and using data science, you're able to determine these sorts of things. Data science is super prevalent in genetics. Most recently, COVID has been happening, right? And when we're talking about COVID, all we are talking about is data, data, data. You search in COVID tracker, you get a COVID tracker, bring back a bunch of data. If we talk about the efficacy of the vaccine, all those trials are talking about the data of how many people got COVID versus didn't get COVID. Did they have the vaccine or didn't they? And we're able to analyze whether or not the vaccines are efficient from that. Engineering, of course, has many applications of data science. There's just so many different applications of data science that's really important for a lot of people to learn this. Of course, when we're collecting all of this data, right, it's one thing to have a massive data set, so you can have millions of lines of rows of data, but we don't know anything new from that if we don't do something with that data. So the way that we gain insights from data is via computation. And back in the early 1900s, there'd be a role literally called human computer, where humans would crunch numbers. And today we've grown, obviously, and we have machine computation that can either be your own laptop or that can be server racks filled with different processors and hard drives. So in this class, we're going to focus on machine computation. And Larry Page says, find the leverage in the world so you can be more lazy. He is the founder of Google. This is a good quote because we want to offload the work that we would normally do onto machines, because machines are very good at a specific task, right? They're faster, they're more reliable, and they can churn through more data. This will help us save some of the human work that we would have to do. In particular, though, right, we can't just tell machines to go off and do the problem, because machines don't understand problems like humans do. There has to be this sort of translation that happens from human to computer. So you're an expert. I did a poll this morning in class. I asked students that were non-CS majors to raise their hands, and a good majority of the room had raised their hands. A lot of the folks taking this class are from other departments like mechanical engineering, biology, psychology, other majors to name some. And you are becoming, or you are a domain expert in your field. Our job in this class is to teach you to help write code, to be able to do that data science portion to further your research or whatever you may be doing in your major area. So the goal for this class is really about becoming bilingual. It's speaking language you already know, whether that's journalism, engineering, civil engineering, whatever that may be, but also to speak the language of computing. So that's our goal in this class. We're going to be combining inquiry, statistics, programming, and communication to gather insight from this data. So you've taken 220, you probably had the option to take CS200 instead. So what are the differences here? Well, your typical class like 200 that teaches Java as an intro language. It's a bunch of CS students, so it's not necessarily students from other majors. Normally it's pretty focused on those students who are getting into CS. And it's very heavy on the theory and not so much on the data. In this class, we're focusing on the data and less on the theory, so practical applications using Python. We're going to be doing a lot of coding in this class, so there'll be plenty of live coding examples. It's not always going to be me up here lecturing to you, but rather you working alongside with me on some problem. And we're going to emphasize questions and communication. So in the next couple of slides, we're also going to talk about the different platforms available for you to get help. Beyond all of this, if you're looking for more reasons why to become a data scientist, it pays well. That's always a good perk of a job. And, you know, this is from Glassdoor, so take it as you will. It says Java developers are happy people, right? Whether that's true or not, that's up to you to decide. But I can tell you for sure, data science is a well-paying field. And then lastly, maybe for altruistic reasons, you want to get involved in data science. So plenty of problems in this world, and data science is going to be the one way that we solve this. You can either go to ourworldindata.org or sdgtracker.org. The second one here kind of lays out the top goals, the global goals for the world, whether that's reducing poverty, trying to address climate change, or make sustainable and renewable resources. All of these decisions that we have to make are going to have to be backed up in data. And when we make a decision, we're going to have to measure whether that decision is effective or not via data. So data is not only applicable to your specific domain, it's applicable to many domains, and it can really be one of the forerunners in tackling these large world issues that we're trying to address. So today, I'm going to briefly introduce who I am and who the course staff are. I'm going to do a brief overview of the course, and then we'll navigate the website. So you saw at the beginning of the slide that there's actually 3 instructors. So this class, this section that I'm teaching, it's a section of 150 students. 2 other instructors, Mina and Andy, they're helping teach 600 other students. So there's 750 students in this class overall. So it's a pretty big class, and we have a great team to help instruct that. Mina's research is in internet measurements and CS education, and you can see that is a very data-centric research field, and she enjoys running. Andy works with a lot of the K-12 community in computer science education. So if you ever take CS402 or 502, those are the computer science service-based learning classes where you go out in the community and you teach computer science, or you learn about computer science education. Andy is a big participant in that. He also works on the college board. He was an AP computer science teacher, I believe, in Madison for a while. He also enjoys running, and he's a member of the barbershop course. And then my name is Cole, and for all of us, please just call us by our first name, Cole, Andy, and Mina. That's plenty. That's perfectly acceptable. My background, I've had internships in cybersecurity and software engineering. I've also worked with after-school programs and workshops before, but obviously you all are much different than 4th and 5th graders. So that's super exciting. And actually, if you've ever worked with Scratch before, which is a really popular language for elementary and middle school, that's where my research is in right now. We've got a large Scratch data set, and we're trying to analyze that data set via Jupyter, which we'll be using in this class. I too couldn't be left out of the running team, so I enjoy running as well. The last person who you might see a little bit of is Tyler. Tyler originally founded this course, and he now teaches CS220. So if you decide that you're really interested in data science and you want to bring this on again next semester and learn more about it, you'll probably take a class with Tyler. His interests are in typing efficiently and civic hacking, which again are both very data science oriented research areas. So to get to know a little bit more about you, we obviously can't have everyone introduce themselves, but what we're asking is that you fill out this Google form. It's called the Student Information Survey, and it's part of your grade. It asks some basic questions like your first and last name and your email address, and then it also asks some questions about yourself. So it might be like, are you a procrastinator or not? What's your favorite pizza topping? And these are all going to be used in data sets later on in the semester, so we can use data that we create as part of our projects in the upcoming semesters. As a part of this, make sure that you're filling out these forms, that you're logged in with your wisc.edu email account. So if you ever see a screen that says you need permission, make sure that you either sign out of your current Google account, or you sign into an incognito window and you sign into your Wisc account there, because this is only available for wisc.edu email accounts. So typically, I take a break here and ask for questions. If you do have questions, of course, you can ask on Piazza, and we'll get into communication and what that looks like in a little bit. So the topics covered for this course, there's three main topics we're going to cover. You're going to cover control flow, state, and data science. The first two kind of lead into the last. So if you think about the computer sitting in front of you, how does it actually work? We know that we type stuff in or we move our mouse around and then something happens and then we get some output, right? Something changes on the screen or it plays some sound or something like that. What actually happens in that black box there? That's what we're going to be unpacking this semester. And there's two primary things that a computer uses. It's called the von Neumann structure. There's state, which is the current windows and data inside of your computer. And then there's control flow, which is the steps that the computer takes for changing that state. So control flow is all about if then. So for example, if I highlight the section of text and press the backspace, then that text is going to be removed from the state. And we'll be spending plenty of time learning about what control flow and state is. We're going to get into deeper subjects of it too. So specifically with state, we're going to talk about structuring our data and saving data in files. And both of these two topics, state and control flow, they're going to lead into the third segment, which is all about data science. So how can we learn how can we apply what we've learned about control flow and state into real data sets? So we're going to take real data sets from the internet and we're going to plot those out on our screen and gather insights from that analyses. Lecture, like I said earlier, it's not going to be me primarily talking at you. It's going to be kind of almost side by side. So we'll talk about the general concepts and the slides are going to be there as a reference point during our discussion. But a lot of our time is going to be spent going through the worksheets and doing live coding on the screen. So the worksheets, actually we're going to do a worksheet on Friday, is where we go ahead and work through a set of problems and coding. As you can imagine, we'd have Jupyter Notebook up on the screen and we'll work through coding problems with you. This is intended so that you can be active in the classroom, right? We want you actively learning. So before the class, you can go ahead and download the template file if there is one for the day and code along during the lecture. I'll bring worksheets in for the days that we have worksheet practice, like this next Friday. And the readings you can do before or after. They're really meant to supplement what we learn in the classroom. Please be sure also to ask questions during the lectures and during office hours. Again, this isn't going to be me just talking at you. It's us learning this together. And office hours are, of course, a great place to get help because you'll get that one-on-one guidance from either an instructor, a TA, or a peer mentor. So, of course, we couldn't get through a slide deck without a picture of cheese here. So, to avoid holes in your knowledge, we're really going to want to build up these rungs, build up the idea of state and control flow so that we can get into more interesting topics. And in my personal opinion, each one of these is interesting. Functions, conditional loops, and lists, these are all fundamentals to programming, no matter what language you choose. And then we'll be applying these to data science. So pandas is specifically used for data, working with databases, and then we'll learn how to plot that data that we're working with. So it's all about building this ladder up so that we can, our knowledge is going to build on top of each other. Okay, lab is happening this week. So if you are in my section, section 4, your labs are all on Thursdays. Please attend labs. They are mandatory this semester. And before you attend lab, make sure that you're installing Anaconda. That installation video is up on Canvas. I believe it's up on the course website. It's up on the introduction email, so you should be able to find the guide to install Anaconda 3. Attendance, like I said, is mandatory. There's going to be 13 labs, and we're going to allow 3 to be dropped. These are really for circumstances where you can't make it to labs, so either for illness or for some other circumstance, but we're really saying attendance is mandatory this semester. It's going to be about 75 minutes long, and it's led by a teaching assistant and a peer mentor. You're going to be in a room. You want to bring your personal devices, and they are going to go around the room and check in on how you're doing on the lab and kind of facilitate that discussion. The lab is going to be posted every Wednesday. It might even be posted on Tuesday, and it should be done during your lab. So don't go ahead and do the lab before. Don't do the lab before the lab. Do the lab during the lab with the TA and the peer mentor. In addition, you're allowed to have a partner for this lab. We'll talk about that in a little bit. All of the folks in my section are from CS220. So as a CS220 student, you can partner with another CS220 student. It's advantageous to do this with someone in your lab. You don't necessarily have to, but if you do it with someone in your lab, you'll be able to work with that same person on the project. So you'll be able to work on the lab and then the project together. If you partner with someone outside of your lab, then you're going to have to work on the lab by yourself, and then you can work on that project with that partner. So it's really advantageous to choose a partner from your lab if it's possible. And then lastly, there is a lab switch request form on the website. This isn't for 9:30 a.m. is too early in the morning. I'd rather come in at 4. This is, I have an unavoidable another lab or discussion at that time, and I need to switch to a different one. We'll work with you as best as we can to make that happen, but that is a process. So only use this if it's absolutely mandatory, and we'll try our best to make that work. Like I said, we don't have any 319 students in our section, but they would diverge off of us. Their labs would be all self-guided, and then they would only partner with 319 students. But again, this is a 220 only section. So we're going to talk a bit about the readings, and my personal favorite book is the Python for Everyone book. It's a Runestone interactive book, and if you've ever worked with a Runestone interactive book before, you know that you can code with inside the textbook. So super helpful to be able to code alongside what we're currently doing. The other 2 books we're going to be using is Think Python and Automate the Boring Stuff. These are awesome references as well. Again, these readings are meant to supplement what we do in class, and they can be done before or after the class session. Lastly, the course notes will also be a good reference because we will be doing a lot of live coding and worksheets. You might want to reference back to the slide notes about more information for that particular day. And the readings are all free as well, so you do not have to go out of your way to buy these books. They should all be available online. Okay, let's talk about class communication a little bit. So office hours are going to be your best way to get help. And it's going to be one-on-one help that you can get with TAs, peer mentors, or instructors. And you can see those office hours posted on those Piazza posts there. Again, I would really encourage you, especially early in the semester, to go out and seek that help and get it. There is 750 students in this course. I believe there's about 40 to 45 course staff. Seek out that one-on-one help and use it as you can. Piazza is probably the best next way to communicate. We're asking that when we get to the coding assignments, you don't post more than 5 lines of code. More than that would be considered cheating. And we also check that before you create a post, because there's so many students, you see if that post has already been made and answered, because otherwise Piazza will really start to bloat and it'll be hard to keep track of things. There's going to be a pinned post of all those office hours as well, so you can see what's going on or when those office hours are for class. Email from instructors is going to primarily come from our Google Groups email address, and this goes strictly from us to you, as well as the no reply email address. If you try to reply to a no reply email address, you will receive no reply. So if you want to reach out to someone individually, make sure that you're using their email address. But if you can, keep questions to Piazza because it's much easier to organize there. Also, if you don't get a response within 48 hours, make sure you let us know, and we'll get back to you then. There are plenty of class forms on the class website as well. So there's a feedback form that you can give us feedback either anonymously or non-anonymously. If you had a TA or a peer mentor that did an excellent job during your office hours or during your lab session, give them a shout out, and we'll give them a shout out during our lab. Use that form liberally if you want to. It makes the TAs, and it really honors the work that TAs and peer mentors are doing. If you have an exam conflict or there's grading issues, there's a form for that as well. And there's also a form if you need to request to switch labs. So we'll go over these when we tour the website in a little bit. The projects are also going to be submitted online, and this is a two-way communication between students and TAs. So as you can see, if you haven't noticed this along the way, the right-hand side where we have the arrows going, that's the direction of communication between whom. So students and TAs, this is a two-way communication channel. You submit your projects through the website, and you get feedback from TAs through the website. So when you submit a project, it'll be auto-graded within a couple of hours, and then TAs will make some comments on it when they get to grading it, and you'll be able to see those comments through the website. And Canvas is a really one-way communication. We're going to push our quizzes and grades through Canvas, and all course information will be available on the course website, but Canvas is going to primarily be about pushing information. All right, let's talk about grades for a little bit. So there's going to be 13 projects this semester, one project for every week. The first project is weighted at 1%, and all other projects are weighted at 4%. And this is going to be using what you learned in the lab and applying it to the project. Quizzes, there's going to be 10 of them, and we drop the 2 lowest, so it equals out to be about 2% per quiz. Labs, there's going to be 13 labs, and we drop the 3 lowest. Again, these are used in cases where you cannot make it to lab. That's why we drop the 3 lowest lab scores. And then 30% is going to come from exams, 10% from each one. There's also 1% of the grade, which is really easy to get just by filling out the surveys and signing up for Piazza. For CS319, it changes a little bit. There's less projects, but there is a final project, self-guided final project. Again, we don't have 319 students in this section, but that's what they would be tackling. Letter grades are pretty straightforward in this class, so what you see is what you get. So 94%, if you get that, you have an A. If you have a 92.98%, that'll be an AB. These cutoffs are strict, and we will not do any curving either up or down. So you'll know by looking at your grade what score you'll be getting when it comes time to submit those grades. Okay, projects have been found to be very useful by students in the previous semesters. So this is from an APHIS course survey. They are very relevant to what we do in the lectures and labs, so attending those is what will help you during the projects. Projects are going to happen every week. They'll be due Wednesdays at 11:59 p.m. So not this Wednesday, but the following Wednesday, February 2nd, I believe, is when the first project is going to be due. That first project, you can get started immediately after the lab. So after your lab on Thursday, you should be able to get started on that project, and it'll be due Wednesday at 11:59. As far as late days go, a project is allowed to be submitted up to 7 days late. If it's submitted after 7 days, then we will no longer be accepting it. In addition, you get a bank of 12 late days where you can apply up to 3 on a single project. These will get applied automatically. You don't have to worry about emailing us telling us that you're applying late days. They'll be applied automatically, and they'll be drained from your late day bank. So 12 late days, you can apply up to 3 late days on a single project. After that, it's a 5% deduction up until 7 days. After 7 days, the project will no longer be accepted. As far as getting help for these, office hours is always probably the best place to go after you have completed your lab. So make sure that you're attending your lab session, you're completing the lab, and then you can attend office hours to get more help. Labs will not be submitted, projects are submitted. So labs are for your own sake, but the attendance is mandatory. Projects are what actually get submitted to the course website. And then last but not least, Piazza can be helpful as well. Just know that when it comes to helping out with projects, it can get really complicated on Piazza because there's a lot of back and forth communication that happens, and Piazza isn't the best place to facilitate that. Office hours is where you're going to find the best help with your back and forth communication. In addition, you can choose to partner with someone. I think I had mentioned this earlier on. So as a CS220 student, you can partner with another CS220 student in another section. You can switch out after projects if you choose. The important part is if you choose someone, you can only work with that person for the lab. You can't work with someone else for the lab. You have to work with your project partner for the lab or work by yourself. So how we're requiring partners to work together too is that you work side by side. So this here shows the way that you should be working with each other, where both partners are working on the same project at the same time in the same place. What we don't want to happen is something like this, where one partner works on the first half during the day and another partner works on the second half at night. So you're not allowed to work on different parts of the program. You're not allowed to work on different times of the program, and you aren't allowed to work on different programs. So partner 1 can't take program 1, partner 2 then takes program 2. That's not going to be allowed. It has to be the case where you're sitting side by side working on the program together at the same time at the same place. Pair programming is super helpful to you because you get someone else's eyes and you're able to communicate back and forth and think out the problems out loud. So this is for your benefit as well, because a partner is there to help you learn how to code, not to complete part of the project for you. How these project submissions work is that you're going to take your project and we're going to give you some test cases to run it against on your machine. You go ahead and you run those test cases on your machine and you'll get a pretty good idea of what score you're going to get. And then once you're confident, you go ahead and submit your project to the course website. And once you submit it to the course website, eventually it'll be picked up by the auto grader every 4 hours, I believe that runs. It'll run your program against its tests, and that will give you the tests run on the server. The TA will look at it as well, and they may take off points for an incorrect solution or poor code styling, and then you get that feedback back from the TAs. So usually the tests that you run on your machine are pretty predictive of what score you're going to get, but just know when you submit it, you might lose points based on poor code styling or it not working on the server. Also make sure that when you get this code review, when you get this feedback back from your TA, that you take a look for it. Even though you might not lose points for certain items, that code review is still going to be valuable for future projects on how you can improve. Okay, and the last agenda item here is about quizzes and exams. So there is no quiz this week, but I believe that we have one opening up next week. They will be due Friday at 11:59 p.m. So if we go back to thinking about projects for a little bit, projects were all about writing code and submitting code, right? Quizzes are more concept oriented, and they are going to be open book and open note. They will be on Canvas as well. And you're going to be allowed to use Python to complete your quizzes too. So open book, open note, open Python. However, when you get to the exams, it's going to be in a lecture hall setting. So it's going to be multiple choice across 2 hours in a lecture hall like Psych 105 where a lecture takes place. Exams will not be open book and they will not be open note, and they will not have Python either. So just know that these quizzes are kind of like quick check-ins to understand if you're getting the content. Exams are focused on the content, so you are not allowed to have open book or open note for those exams. Last thing I wanted to walk through is the website. Let's go ahead and open that up. Just 1 second. Okay, so this is the course website. It's run underneath Mina's domain, and you can get an idea of what we're doing throughout the semester just by glancing at it. So as we had talked about earlier, there's 3 parts, and they're split up here with these different dividers. And you can also look at previous semester's slides by changing this S22 to fall 21. Obviously, we're not going to follow what happened last semester directly, but everything is going to be based off of fall 21 relatively. So check out the schedule. I will post, sometimes there will be code templates posted here. I will post my code template, Andy will post his code template, and Mina will post her code template as well as any relevant materials for the day should be found on the schedule. The syllabus is what we covered today. I would recommend you read through this as well, but this should cover what we had talked about in the slides today. In particular, there's a couple more insights on how projects are graded and how quizzes are graded and how exams will be held, so it is helpful for you to look through the syllabus as well. The projects tab, this is where you're going to be submitting your projects from. So let's say, I believe I was signed in. Let me sign in real quick. I could have been signed out. Yes, you want to sign in with your Whisk email address, and this will allow you to submit your projects to the course website. So I'm signed in as myself. I can choose project 1, and then I could upload the Jupyter Notebook file for my project here. I already went ahead and did that actually, so I can press View Submissions, and this is going to be where I get feedback from my TA. So if we let this load here, we can see I made this submission yesterday. The autograder picked it up and it's passing already. So again, this autograder only runs about every 4 hours or so, and you'll only get general TA comments back when the TAs have looked at it, which is not going to be every 4 hours, obviously. So this is where we're going to manage all of our project submissions at. In addition, there's going to be a class forms tab. So this is where you're going to want to make sure to fill out the student information survey. This counts as part of your grade, as well as all the other forms that we had talked about earlier. The resources tab, I don't know if the late days is working yet. This is going to tell you how many late days you have left from your 12. Then there's links out to our Piazza office hours posts, as well as some old exams and the data sets. And then lastly, the tools that we're using. So Piazza, Canvas, Python Tutor we'll get into later this semester, and I don't believe you'll have access to the TA only tab. So this is the course website in a nutshell. This is where you should go to for all of the course materials. Let's switch back to the PowerPoint. Okay. And with that, that is all I had to present on today. So again, make sure that you fill out that student information survey. Also be sure to read that syllabus that we had just shown on the screen. It's really important that you set up Anaconda before you attend lab because it can take some time. And if you're running into issues with setting that up, please do use office hours. You'll need to have this set up in order to do lab P1. And then finally, after you have attended your lab, which I believe is on Thursday for everyone, you can go ahead and get started on that project. And that project will be due by next week, Wednesday at 11:59 p.m. So if you have questions, please attend office hours or let us know on Piazza. Thank you.